Well, good morning. It's 11:04 on Tuesday, the 5th of December, 2017. It's supposed to be linear algebra class. Right now, I'm the only one in the room, so hopefully some other students will be coming. But until then, let's get going. Have a few announcements to make first, and really want you to listen closely and pay attention to these because they are important, okay? First and foremost, please, folks, if you haven't done your student course evaluation, please do the student course evaluations. Very important. There's really a big emphasis on right now to get these done, so please, everyone, do the student course evaluations, okay? They want 80% done. And with only 2 people in the class, that's both of you folks. Only one of you do it, that's 50%. We won't make 80. So both of you, please do the student course evaluations. Now, another thing, while I'm thinking of it, it has nothing to do with math or anything else, but next Tuesday, 1 week from today, is voting day. It's the special election for the U.S. Senate. I want everyone, if you're registered to vote, please vote. Get into the habit of voting every time the polls are open. Right now we have such terribly low voter turnout. We are not a democracy right now. We're just a small group of people, special interest groups, are showing up to vote, and they're deciding our elections. So please, folks, get out there and vote, okay? Now, enough of that. Let's go over how we're going to wrap things up, okay? This is linear algebra. I have only received one of the 2 research papers in. Thank you for that one, but the other one I do need in before Thursday or by class on Thursday, because otherwise you start losing points if they're not in by Thursday. Okay, I've gotten both tests in, first test in. I've returned those to you, I hope. If not, you should get them. And I've received both of your second tests, and I hope I've returned those to you as well. If not, I will return those. Your third test, you still have. Please get those in as soon as you can. I don't have either of those yet. And then I'll be giving you the test on Chapter 4. That will be your final exam. It won't be comprehensive, just be the Chapter 4 test as far as we get today and Thursday. Okay. Let me tell you a little bit about how we will meet in class on Thursday as normal. Office hours today are, today and Thursday, by the way, are 1:15 to 3:15. And then on Wednesday, that's tomorrow, 3:15 to 5:15. On Friday, I'll be on the Birmingham campus, 7:45 to 11:45. And then next week, finals week, is sort of a strange schedule, so let me explain it to you. Monday morning at 8, when I normally have an 8 o'clock class, we are going to have a review session for the final exam. That will go from 8 o'clock in the morning until 9:50, almost 2 hours. Anytime after that, that class can take their finals. Leaving it open for them. Anytime they want to come in and take their final, they can. Okay, so that means that anytime during the rest of the week, I may be giving a test at any time, any place, any day. Okay, any day. So where will I give those tests? Well, let me back up. If you're looking for me during finals week, the best first place to look would be in my office. Now, if I'm not in the office, I'm probably giving an exam. If it's a scheduled exam, I'm up here in 255. If it's not a scheduled exam, it may be anywhere between 255 and 265. Closer to 265, because I want to stay close to my office as possible in case people are looking for me, and so I can hear the phone ring and that kind of stuff. And when I have to go back and forth to get more materials, it's easier than coming all the way up here. So, so that's why I'm telling you where I'm going to be when. So 8 o'clock until 9:50 Monday morning during finals week, I'll be in this classroom, but I'll be doing a review session. Not a good time to come by and ask questions and stuff like that, because I'll be doing a review session. But anytime after 9:50, for the rest of the day until 5:15 on Monday, I should be either in my office or in a classroom between my office and here, 255, between 265 and 255. Tuesday morning at 8 till 9:50, I'm giving an exam, and that will be here in this classroom, 255. And once 9:50 is over with, or 10 o'clock, somewhere around there, anytime between then and 3:15, I'll be either in my office, probably in my office, but if not, in a classroom between my office, 265, and this room, 255. Maybe up here, if all the rooms are occupied. If not, I'll be in one closer to my office. Okay. 3:15 on Tuesday, of not today, but next week. Unfortunately, it's a mini-term course, so that's a regular class day for that course. So I'll be in class, doing class from 3:15, technically until 7:45. The odds are we will finish early. Once we finish that last chapter and do the last lab, then the students will be taking off and going. So I'm not going to say I'll be up here in this room from 3:15 to 7:45, but I'll be here for a good chunk of that time. And until they get everything done, then after that I'll go back to my office or any room in between if people are doing makeup tests. I'm guessing that late on Tuesday afternoon they won't be. Okay. That's Tuesday. Wednesday, I have no scheduled finals, so therefore the best place to look is in my office, 265. If not there, look in any classroom coming this way from my office, 265 up to 255. If someone comes by to do a final, then we'll go to a closest classroom that's empty, and I'll be doing the final there. Okay? It could be as far away as 255, this room here. The odds are, hopefully, it'll be something closer. Okay? That's the rest of the day. That's all day on Wednesday. On Thursday, from 7:45, 8 o'clock in the morning until 3:15, I should be in my office or in some classroom between my office and here, between 265 and 255. Now, at 3:15, technically, that's when my final exam will be for that mini-term 2 class. Now, I've given that class the option that if several of them live out of state, and well away from the Birmingham area, so I've told them that if they want to take their last test and their final early, they can, and they can come around anytime. Those are some of the makeup tests that I'll be doing. They take their finals, and if and when they do, I'll be in any room between 265 and 255 giving those tests. If some of them wait till the final exam date, which is Thursday, 3:15, then we'll be up here in the classroom at 3:15. I think all of them will be through by 4 o'clock because the final is not that long, and I think they'll be through by 4 o'clock. So sometime after 4, I'll be back in my office or in some classroom in between my office and here. Okay? And then on Friday, I'll be on the Birmingham campus. That's both this Friday and next Friday, 7:45 to 11:45. And then I need everything completed by then because I can't remember for sure what the grade report deadline is. Usually it's Monday noon after final exam week, which would be the following Monday at noon. I have to have everything done. So please get me your stuff next week sometime. This week or next week. Anything that's due already, get me this week. Anything that's I give you for the finals, get me in this week or next week. Okay. And as soon as I get everything graded, I'll put it on Blackboard. And let me tell you this in case you're not familiar with how we do things here. Right now you can access Student Suite anytime you want to. Okay? Not next week. Okay? Our old system that we have here, there are only something like 16 or 32 portals that you can access the system by. And if all the students are looking for their grades, then they clog up every portal we have, and then we, the instructors, can't put the grades in. And we went through this the first time that we went to this old system, and it was miserable. So what they've started doing is during final exams week, they block students from Student Suite. You cannot access anything in Student Suite, next week, during final exam week. That allows us to put your grades in, and then the week after finals, after final grades are submitted, then after that you can go back to Student Suite again. So here's what you do next week. Look at Blackboard, because I think most instructors do this. I know I do it. I first put everything in Blackboard before I put it in Student Suite, in the Suite anyway. So if you don't see it in Blackboard, it's not going to be in the Suite anyway. If you do see it in Blackboard, it may not be in the Suite, but it's going to be there very soon. So you'll see it first in Blackboard. Go there, check. That's how you see what you're doing, what you did on the test, that kind of stuff. So that's during finals week, and up until final grade reports are due, you cannot access your Student Suite. All right. Hopefully that's going to answer just about everything you've got. Let's continue where we were. We're in Chapter 4, Vector Spaces. Section 4.2 is also named Vector Spaces. And we're on example 4 there. We were looking at different vector spaces. Now, these are not our classic vectors, directed line segments. These are anything that classify as a vector. Example 4 is talking about polynomials as vectors. The vector space of all polynomials of degree 2 or less. And we call that space, let me get my pen activated. We call that space P2, polynomial of degree 2 or less. Let that be the set of all polynomials of the form P of x is equal to a2x squared plus a1x plus a0, where a sub 0, a sub 1, and a sub 2 are any real numbers, okay, a1, 0, a1, and a2 are real numbers, any real numbers, and the sum of two polynomials, okay, so that's your vector space. Now that's your set. Is that a vector space? Well, here's the things you check. First, does it obey the vector sum rule? In other words, if you add any two polynomials, say this one plus p, let's call that p1x, this is p2x, where this would be b sub 2 x squared plus b sub 1x plus b0, add any of those two together, is that in the vector space? Yes. You can't come up with an x cubed there if you're adding polynomials with degree 2 or less. You can't add it together and get anything with degree 3 or more. So, yes, that will still be a polynomial closed under vector addition. Okay? Now, our vectors are polynomials. Remember that, okay? Now, and they called it Q. I'm sorry. I called it P1 and P2. They called it, well, there we go. They called it P and Q. Doesn't matter what you call it. I can't get it to come up. There we go. P and Q. Okay? Now, where the vector addition is given in the usual way, you just add those two together. There's you a2 plus b2 x squared plus a1 plus b1 x plus a0 plus b0. Those are in that space. Okay? The scalar multiple of px would be, for any c, a real number c, scalar multiple c p of x would be ca2 x squared plus ca1 x plus ca0, and that is also in the vector space, in that set, because a, b, and c can be any real numbers, so c being a real number, C times A2 is any real number, C times A1 is any real number, C times A0 is any real number. So that's in there, okay? Now, you fit those two. That's how we define our addition, and we find our vector addition and scalar multiplication, okay? Now, does that define a vector space? Well, you could go through all 10 of the rules, okay, definitions that we had, but we've already done one. We've already basically done two. That follows from adding polynomials. It doesn't matter what order you do. If you had 3 polynomials in there, all degree 2 or less, add them together. It doesn't matter what order you do. The other one down, number 4, this is important, that there is a 0 vector. Well, the 0 vector would be the 0 polynomial. That's of degree 2 or less, and that would be P of x equal, or Q of x, or 0 of x, whatever you want to call it, would equal the 0, okay? It would just be 0, okay? So it does have the 0 vector, and you add that to any other vector, and you get the same vector you had to start with, and you add to P of x, which is a2x squared plus a1x plus a0, add to that minus a2x squared minus a1x minus a0, and you get that 0 vector, okay? Scalar multiplication, we've already said it's closed. If you add 2 vectors and multiply by scalar, you get all the other things work really well, and 1 times any polynomial is the original polynomial. So sure enough, everything works. That is a vector space, this set of all polynomials degree 2 or less. Okay, let's move to example 5. This is a vector space of continuous functions, okay? Now they're calling this calculus. It's fine to call it calculus, but it's anywhere. So this set, you always start with the set. Here's set C, and it's defined from minus infinity to infinity. You could have other limits if you needed it. Let that set C be the set of all real valued continuous functions continuous functions defined on the entire number line okay? That set consists of all polynomial functions, all other continuous functions on either on the entire real number line. So your trig functions are there, your exponential functions are there, everything that's defined everywhere. I'm so glad you're here. I get tired of talking to myself. So Jasmine's here. Whoops, yeah. You got it. Yes. Okay. Okay. I think I've asked you this before, but I'm just saying it every time anyone comes in. Have you done the study course evaluations? Yes, I thought so. Okay. You know what next Tuesday is?
Election day.
Election day, you got it. Be sure you vote, okay? If you're registered to vote, be sure you vote. I've got to vote on my way into work that morning because I don't get off next Tuesday until 8 o'clock and the polls close at 7. So I can't possibly vote on the way home. I've got to vote on my way in. So I already told my first class this morning, even though they have their final exam that morning at 8 o'clock, I said, look, I'm going to do everything I can. I'm glad you pulled that out. It reminded me of something. You had left this in the class last Thursday. That wasn't yours, was it? Okay. I meant to pull it out this morning before my first 2 classes. I forgot to do it. So so I'm going to put it out here for my last class. This class is next. I don't think it's chemicals, but if it is, you'll see it. Okay, so I told them I'm going to try to be at the polls before they open at 7, but I'm hoping it's going to be a huge line. I'll be near the front of it, but I hope there's a big turnout and there's a big line, and I'll get voted as soon as I can and then rush to campus. Hopefully I'll be here before 8 o'clock, but I can't help it. I mean, I've got to vote, and I can't vote afterwards, so I've got to vote beforehand. Okay. Other things. You turned in your research paper, so good, in both classes, I think, right? Okay. And you've turned in your first class. I think I gave it back, test in this class, right? I gave it back to you, I believe, right? And then the second test you turned in, I think I gave that back to you, didn't I? Not. Okay, well, let me get that to you now. The second test, wait just a second. The first test was chapter 1, second test was chapter 2, and the third test was chapter 3. And here's your second test. And I must have already given Kimmel his one day he was here and you weren't. Okay, but your third test I don't have yet. So,
yeah, I'm sorry, maybe today.
Okay.
Did you give us another two?
No, I'll give it to you Thursday.
Okay.
Day after tomorrow. That'll be your last test. It will be your final exam, but it won't be comprehensive. It'll just be on chapter 4. Whatever we cover today and Thursday on chapter 4. Okay. So, I've returned the first 2 tests to both of you then. Get me your third test, and I'll try to get those back to you on Thursday as well. No promises, but I'll try. But hopefully when you come to turn in the final, whenever that is, I'll have, if I haven't already given you your third test back, I'll give it to you then. Knock on wood. Okay. Okay. Okay, let me give you, I said this before, but you said you may not go back and listen to it. Let me give you this week regular classes, okay? In other words, I have office hours today and Thursday from 1:15 to 3:15. And on tomorrow, Wednesday, I have office hours 3:15 to 5:15. And on Friday, both this week and next week, on Birmingham campus, 7:45 to 11:45. Okay. Now, next week, don't count on things being the same during finals week, because they're not. They adjust schedules occasionally. So here's my quick and dirty on where my best guess of where I'm going to be during finals week. Monday morning from 8 to 9:50, not 9:15, but 9:50, almost 10 o'clock, I'll be in this classroom giving a review session for my Math 100 class. Okay? So that's not a good time to come see me because I'll be doing a review session for them. If you want to come turn something in, just slide it under my door of my office. Okay. Okay, now anytime after 10 o'clock, I should be either in my office or some classroom in between my office and this room. It could be this room, or it could be right next door to my office, or any classroom in between. Because you see, I'm letting those students in that class come and take their final anytime after the review session is through. If they want to do it at 10 o'clock, they can. If they want to do it in the afternoon, they can. If they want to do it Tuesday, they can. Anytime they want to, they can come and do their finals. So that's why I won't know exactly where I'll be. Best place to look, if I'm not in the classroom, will be my office, and if not, look in any classroom in between my office and here. Okay, so that's Monday from 10 o'clock until 5:15, either my office or some classroom in between. Now Tuesday, I'm giving a final 8 o'clock in the morning in this room, okay, and that'll go until 9:50 or 10 o'clock, or whenever I get here from voting until, whenever. Hopefully I'll be here by 8 o'clock. But that, again, won't be a good time to go over things with me because I'll be giving an exam here. If you want to come in and work on something, you certainly can, because, it's a big class, but not all the desks are occupied, so you're welcome to come in and do. And I'll also be, what was I going to say on that? But if you need to talk with me much, it'll be better to wait till afterwards because I don't want to interrupt the students who are taking the test. So that's not a good time for interaction, but it is a time that if you want to come in. But then anytime after 10 o'clock, up until 3:15 on Tuesday, I'll be either in my office or some classroom in between. But at 3:15, that's a mini-term class. We have class that day. Tuesday of next week, final week, a week from today, we have regular class. So that class will be running from 3:15. Technically, it goes until 7:45 in the evening. I don't think it will go that late because we just got to finish that last chapter and have the last lab. And once that's over with, then the students will be leaving, I think. I'm giving them the option they can take their tests early if they want to, because a lot of them are automotive students who are coming from out of state or anywhere in the state, and they usually have, they like to get away as soon as they can. So anytime they want to take their final, I'm going to let them. So it's not just my 8 o'clock on Monday class, it's also that class will be taking finals anytime they want to. So that Tuesday, I know I'll be in class from 3:15 until somewhere around 7:45. It may be through earlier than that. But then from Wednesday and Thursday, I have no scheduled finals, but I could be anywhere between my office and, well, I'm sorry, I take that back. Wednesday, no scheduled finals anywhere in from my office to here if I'm giving a makeup exam, or in my office if I'm not, okay? Thursday, however, that's technically when that mini-term class final is at 3:15. It won't take them more than 45 minutes, I don't think. So 3:15 to 4 o'clock, I'll be up here in the classroom, if that long, and then other than that, I'll be in my office or somewhere in between. So that's my schedule, and then Friday I'll be back on the Birmingham campus. Now, grades are due, now most of the time it's Monday at noon after finals week. It seems like last spring or sometime they gave us an extra day. So I don't know if they're going to give us an extra day this time or not, but it's either going to be Monday at noon or Tuesday at noon. One of those two times is when, so I really need everything turned in next week so I can get it all graded into Blackboard, into Student Suite, so I can get it in there before noon Monday. If it's noon Tuesday, I have an extra day, but I don't know that that's going to happen. So the week after finals, right? Okay. All right. Any questions? Okay. All right. Now, I had just done example 4 before you got here, and it started example 5. These, I don't know, I can't remember if you were here last time. When we're talking about vector spaces, we sort of have a new definition of vectors. Vectors is no longer a directed line segment. That's certainly a vector, okay? But when we're talking about vector spaces, anything can be in a vector space, okay? R2, those are our regular vectors, two-dimensional vectors. Rn, n-dimensional vectors. It doesn't even have to be space, 3 space. It could be 14 space, okay? Anything that's defined there is a vector space, okay? Matrices can be defined as vectors, okay? Strange but true, okay? They're no longer a directed line segment. They can be vectors if they meet those qualifications. Vector addition is defined, and just like you can add 2 matrices together if they're the same size. Yeah, that works. They can be vectors, okay? Can be classified as vectors. You can multiply a matrix by a scalar, and it follows the same rule as a vector, multiplied by a scalar. So that can be a vector space. Example 4 we did was polynomials. Polynomials with degree 2 or less, that can be a vector space, because you can't add 2 polynomials with degree 2 or less and come up with a degree greater than 2. It just doesn't happen. If you've got 2 polynomials of degree 2 or less, add them together, it'll be a polynomial of degree 2 or less. You can multiply a polynomial of degree 2 or less by a scalar, it stays a polynomial of degree 2 or less. So, and that meets all the standard rules. Example 5 was what I was working on here, the set of all continuous functions. and that's what I was just writing here. If C is a set of real valued functions, defined, that's what that is, I was trying to read my writing, defined on the number line, that can be a vector space as well. Okay? These are real valued continuous functions. Okay? The set of that set, and this is what I was saying before you came in, consists of all polynomial functions, which is what we did in example 4, but it could also be your trig functions, some of your trig functions, sines and cosines only, because your other 4 trig functions, tangent, cotangent, secant, cosecant, are not continuous functions. They have asymptotes, remember? So only sines and cosines. Exponential functions, perfect. They're defined anywhere on the number line. Log functions, not, because log function cannot be defined for negative or 0, okay, value. So it has to be set of real valued continuous functions defined on the entire number line. The ones we're looking at now anyway. Okay. So e to the x, sine x, cosine x, polynomial, any of those are. Now, how do we define vector addition when you're talking about functions? If you have f of x plus g of x, that's f plus g of x. Yeah. Standard way of defining sum of two functions is a function. Okay? Or, if you multiply c times f of x, that's going to be c times f of x. Okay? I mean, that's saying the same thing. It looks a little crazy, but that's exactly what it means. If you have a function, continuous function defined anywhere on the number line, multiply it by a scalar, any scalar, you're going to have a function that's defined on the number line. Okay? So that, both of those, and then they ask you to show that they are that is a, we know it's a set, show that it's a vector space. Well, how do we do that? You go back one page to those 10 elements of your definition. We've already said the first one. Add any two functions together, you get a function, right? Continuous functions. Doesn't matter what order you add the functions, u plus v or v plus u, you still get the same value, okay? It doesn't matter how you group the functions. If you have 3 functions, f plus g plus h, or f plus g plus h. It doesn't matter, it's, you know, commutative. The 0 vector is your 0 function. F of x equals 0, okay? That has to be in there. If you didn't have that, it's not going to be a vector space, okay? But then also, for every function you had, let's just say e to the x, you can add to another function, minus e to the x, and get the 0 function. No matter what function you have, you can add its negative, and you'll get the 0 function, okay? Scalar multiplication, we've already defined it. And if you had the scalar multiple multiplied by the sum of two functions, you add the two functions together and multiply, or you multiply each one of them separately and then add them. It doesn't matter. Okay? All those rules on the previous page that qualify you as vector spaces, if all those are met, you've got it. Okay. So here's the summary of the important vector spaces. Okay? Let me erase this. R. That is the real number line. Set of all real numbers. Set of all real numbers. That's a vector space. Because you add any two real numbers together, you get a real number. Multiply by a real scalar, you get a real number. Everything works just like that. Now, R2 is the plane. Any two vectors on the plane, add those together, you still have a vector on the plane. Multiply a vector on the plane by a scalar, you still got a vector on the plane. All the things of this. So this is the set of all ordered pairs. Okay, and that would be points on the plane. R3 is the set of all triplets, ordered triplets. Okay, and this would be space, all of space. Any two vectors in space, add them together, you'll still be in space, 3 space, okay? Multiply a vector in 3 space by a scalar, you're still a vector in 3 space. You can have the 0 vector in 3 space. Everything works, okay? Rn would be the set of all ordered n tuples. Okay? In other words, if n was 17, x of 1, comma x of 2, comma x of 3, comes to x of 4, comes up to x of 17, that's an n tuple. Add any two n tuples together, and you get an n tuple in the same space. Yeah, as long as they're the same size, it works. Okay? Continuous functions from minus infinity to infinity. That's a vector space. Set of all continuous functions. Okay? Defined on the real number line. Now, here's another one. C on some interval a to b, closed interval a to b. Set of all continuous functions defined on a closed interval a to b. Now, okay. Yeah, that's no problem either. Because if you add any two functions defined on a to b together, you're still going to have a function that's defined on a to b. Multiply a function on a to b by any scalar, and you'll still have a function defined on a to b. So that's interesting. It can be infinite or it can be restricted domain. Okay? P is a set of all polynomials. Okay. And P sub n is a set of all polynomials of degree n or less, degree less than or equal to n. Okay? So basically, set of all polynomials is certainly a vector space, all possible polynomials, but you could also restrict it to polynomials of degree n or less. So if you started off with degree 7 or below, then you add any two 7 or below together, you're still going to have a polynomial 7 or below. Multiply by a scalar, you're still going to have a polynomial 7 or below. Okay? Now, m sub mn, now I like to do m by n. This says this. This is the set of all m by n matrices. Okay? Now you have to have your definition such that everything works. You have to have a zero matrix. You know, everything has to be the same. So all m by n matrices. Okay? Subset of that would be m sub n, which would be set of all m by n square matrices. Okay. So those are some of your important vector spaces. You could conceivably have others. These are the biggies, the ones you most normally use. That's just finished page 157. That was the bottom of page 157. That I copied from their summary. See it? Okay. All right. So, I love their little statements. You have seen the versatility of the concept of a vector space. Sure you have. I mean, it's there. I mean, I don't know if you've seen it or not, but anyway. For instance, a vector can be any real number, an n-tuple, a matrix, a polynomial, a continuous function, and so on and so on and so on. But what is the purpose for this abstraction? Why bother to define it? There are several reasons, but the most important reason applies to efficiency. Sorry. Sorry. This abstraction turns out to be mathematically efficient because general results that apply to all vector spaces can now be derived. Once the theorem has been proved for an abstract vector space, you need not give separate proofs for the n-tuples, matrices, and polynomials. Simply point out that the theorem is true for any vector space regardless of the particular form that the vector happens to take. So here's theorem 4.4, top of page 158. Head's clogging up again. I don't know why. I made a special point before class to run to my office and get a little bit of a granola bar and a little bit of soda and stuff just to keep things loose. They did for a while, but that seems to be wearing off. Let's see how we're doing. Yeah, if we can make it another 30 minutes, I'll do that. Okay. Here's theorem 4.4. Properties of scalar multiplication. Nothing too new here. Let V be any element of a vector space V. Vector space V. And let C be any scalar. Okay? Then the following properties are true. Okay? If that's true, then these things are true. First, 0, the number 0 times that vector V, okay, is going to be the 0 vector. Okay? I'm sorry, I don't know what I was doing that symbol for. What I meant to do was, okay, sorry. Okay. If the number 0 multiplied by any vector V that's in this vector space, now remember this vector space can be polynomials, matrices, continuous functions, anything, okay, that fits. And if you multiply 0 by it, you're going to get a 0 vector in that space, in that kind of setup, okay? That's number 1. Number 2. If you multiply a scalar times the 0 vector in that vector space, again, it could be a polynomial, matrix, or whatever, you are still going to get that vector, okay? Because the C multiplied by 0, you lose the C, okay? The meaning of the C. Okay, number 3. If C times the vector V in that space, now it doesn't have to be a directed line segment, any polynomial, continuous function, matrix, whatever it is, if C times that is equal to the 0 vector, okay, then we know that either C is equal to 0 or V is equal to 0. You can't compromise on that. If the product of a constant, a scalar, whatever it is, times whatever your vector is. If that product is the zero vector, either the constant has to be zero or the vector has to be the zero vector. Okay? And number 4, if you multiply -1 times any of those vectors, functions, matrices, whatever, you're going to get the opposite of that vector. Okay? All right. Now, they do a little proof here, probably well worth your effort to look at that. And follow it through, make sure you understand how and the way they do it. There is a linear algebra applied here, a mass spring system. If you're not comfortable or particularly adept, you might say, at the physics part of it here, read through it, see if you can follow what's going on. It's some interesting verbiage, and it's interesting to me they use this place to introduce it and not quite define it, but come close to it. Frankly, I felt like we were begun to be overturned. Let's see, what am I trying to say here? This is talking about the mass spring system, and this is something you do in physics. You've had physics, right, or in it now? Okay. This is basically Boyle's law and Newton's second law sort of mangled together. You have a differential equation, x double prime is plus omega squared x is equal to 0. And that's almost what you see, it's not quite, but almost what you see on the board over there from Dr. Bryant's class. I think I had more of that up here, but I had to erase it so I could project this morning. But this is just showing some features of this and how that differential equation can have a solution and a variety of things like that. We're not going into that. We don't have time, but it would be a pretty interesting thing to look at and follow through. It's interesting in another sense. Isaac Newton, I think, did not get along particularly well with goodness, I can't think of his name now, I just called it. Oh, goodness. The guy who did the spring stuff. I can't think of his name now. But they really did, in a sense, sort of work together okay. They just didn't seem to get along very well. Okay. But I won't go into that anymore. It would be an interesting paper topic, but you've already done your paper. All right, let's now look, since we're looking at systems, sets that can be vector spaces, look at some that are not, okay? For instance, the set of integers, set of real numbers is a vector space, okay? Multiply any real number by a real number, you get a real number, right? But what if you had a set of integers? Multiply by any real number, give me a real number that's not an integer. Say again? 3 is an integer. About 3/2. Okay? Any integer, not any integer, but a lot of integers you can multiply by 3/2, and you don't wind up with an integer still, right? The integer 1. 1 times 3 halves would be 3 halves, okay? Well, 3 halves is an integer, so therefore, under scalar multiplication, that is not a vector space. So a scalar, remember, is any real number. When you multiply any real number by integer, you don't always get an integer, okay? So that can't be a vector space, okay? Now, the set of second-degree polynomials is not a vector space. Well, wait a minute. If you go back to example 4, that was a vector space of all polynomials degree 2 or less, okay? This is the second degree set of second degree polynomials. It's not got the or less part in it. Why is that not a vector space? The set of all second degree polynomials. Why is that not a vector space? Vector addition is fine. Scalar multiplication is fine. Those are the two biggies. But one thing that's not fine, there is no zero vector there. You have to have a zero vector, because a zero vector is not a second degree polynomial, okay? That's why you can say second degree polynomial or less, that can include the zero vector. But second degree polynomials cannot, because 0x squared plus 0x plus 0 is not a second degree polynomial. It's 0. It's all it is. So that is not. Okay? That's the other reason it's not closed under addition. Say you had p of x equal x squared. That's the second degree polynomial, right? Say you had q of x say q of x and wrote q of something else, a or whatever. But all right. Let's say this was minus x squared plus x plus 1. Okay? Let's add those two together. Under vector addition, it should be closed if this was a vector space, and that should be a vector second degree polynomial. But it's not, because when you add these two together, you lose the second degree, and you just have x plus 1, which is a linear polynomial, not a second degree polynomial. So that's why you have to have it phrased second degree polynomial or less. It doesn't have the zero vector, and it's not closed. But if you have the or less in there, it's fine. Notice it didn't hurt. If these are all second degree polynomials, you can't have a third degree in there, but you can't add or multiply by a scalar and ever get a third degree. So you're fine on that scale, but you're not fine on the scale that everyone would produce a second degree polynomial. All right, sorry, my throat's hurting. Here's another one that's not a vector space. I think I'll start with a clean page here. Here is a set of all ordered pairs of real numbers. So they name it V as if that's a vector space, and that's going to be R2. And we know that R2 is a vector space, okay? But it's the set of all ordered pairs of real numbers with the standard right. Oh, I'm sorry. I was reading under example 7 and wasn't seeing how this is example 8. Okay, so here V is a set, and this is a set of all ordered pairs, okay, of real numbers. Set of all ordered pairs of real numbers, with standard operation of addition and a non-standard definition of scalar multiplication. If you had a standard definition of scalar multiplication, fine. But this is your non-standard, and here's what it is. That C times this ordered pair x1, x2 is going to be, here he is, Cx1, 0. Okay? All right. Sort of hate to do this, but I hate not to do it as well. Okay? So Jasmine's heard it a couple of times now, but let me say it again. Time out from where we are here. Today and Thursday are the last 2 days of class. Okay? First question I have for you. Have you done the student course evaluations?
I'm going to do them tonight.
Excellent. Thank you. Be sure you get those done. They want every class to be more than 80% done, and with only 2 people in here, that's both of you. Okay, well, only one of you do it, that's 50%. That's not more than 80. So both got to do it. Sorry. All right. Number 2. I think I've returned. Okay, I don't think I got your paper yet, right? Research paper.
The research. Oh, yeah, the research paper.
Okay, that's.
I'm almost good.
Yeah, that's due on Thursday too. Please get it in by Thursday. You can give it to me today. You can give it to me tomorrow. You can give it to me before class on Thursday or in class on Thursday. But after Thursday, you start losing points. Okay. All right. First test, I think I gave you back. And second test, I gave you back. Okay. Third test I haven't gotten yet. That's the determinant test. And so anytime you can get those to me, if you get them to me before Thursday, I'll try to have them graded. Knock on wood, no promises. I'll try to have them graded and get them back to you on Thursday. But if I get them like late Wednesday, I don't have time to grade them, I'll get them back to you when you turn in your final or whatever. Okay. After class on Thursday, at the end of class on Thursday, I will give you your last test, which is just going to be on chapter 4. I don't know how far we're going to get in it, but I'll only cover what we cover so far. Now, I've got to make it out before class, so I'm going to make a guess. And if I guess wrong, then I'll say, oh, that question's optional. You can do it or not do it. Okay. All right, so that will be, I'll give you your last test on Thursday. Okay.
And then we'll have the Tuesday to turn in?
Yeah, well, you can turn it any time during finals week. Anytime.
And
okay.
whole week next
whole week.
Finals.
Yeah, right.
Okay.
Okay. But everything else has to be in before that. But that test, anytime the following week. The sooner the better. That way I can get it graded and you can see what you got sooner. All right. Was there something else? Okay. Let me give you quickly what my schedule is going to be like during finals week so you'll know when you can catch me and when you can't. First, I'll do this week. This week's a normal class week. So office hours today are 1:15 to 3:15, same on Thursday. Okay. Tomorrow, Wednesday, office hours 3:15 to 5:15. Okay. Friday, both this Friday and next Friday during finals, Birmingham campus 7:45 to 11:45. Okay. Now, so that covers this. Finals week, things change. Okay. And I told this to Jasmine already. Let me say it again. Monday morning, normally I have an 8 to 9:15 class on Monday morning. During finals week, next Monday, it will be 8:15 to 9:50. The full, close to 2 hours, I'm having a study review session for that class, okay? That's when they would be taking their final, but I'm giving them a review session just to give them a little bit more review before the final. After that, they can come in any time during the week and take their final, but they have to take it in class, and I have to proctor it. So that means for the rest of the week, I could be proctoring an exam anytime during the day, okay? So just get that, okay? So I'm not available 8 to 9:50 on Monday morning because I'll be doing a review session. If you want to turn something in then, you can slide it under my door to my office, okay? But if you want to talk with me, wait until after 10 o'clock, basically. And from 10 o'clock until 5:15, basically all that time I'm either going to be in my office or giving a makeup exam anywhere from any classroom between my office at 265 up to this one 255. What I usually do when I'm doing a makeup test, I don't come all the way up here and do it. If I find the classroom closer to my office, I do it there. That way I can hear my phone ring, maybe I can go back and forth to my office more easily while they're taking their test. Okay. So that's Monday. Tuesday, I'm giving an exam in this classroom from 8 to 9:50. So I'll be here giving an exam. If you want to come in to work, you can do that because there will be a few seats left available. But I won't have much time to interact with you because I don't want to interrupt them while they're taking their test. But anytime after 10 o'clock until 3:15, I'll either be in my office or in some classroom in between there and here. 3:15, however, I'll have a second mini-term class. They have a regular class day that day. Even though it's final exam week, mini-term classes have a class day during finals. So that day I'll be in class from 3:15. I doubt if I'll be there till 7:45. That's when it usually goes, but I could be. We're going to finish the last chapter, have the last lab, and as long as that takes, I'll be occupied. If they finish sooner, then I may be back in the office sooner, but no guarantee. I may be up here until 7:45. Now, I'm also giving them the option of taking their test anytime after that last day of class, which means the very next minute. I mean, if they want to, once we finish that last lab, if they want to go on and take their last test and their final exam, I'm going to let them do it because a lot of them are automotive students who are coming from out of state or anywhere in the state, and if this is their last test, I don't want them to have to stay around 2 more days just to take my test and then go back home. So I'm going to give them the option of taking it anytime they want to. So not just my Monday at 8 class, but also that class. Once their last class is over with, they can take their final anytime they want to. Okay, so that gets us through Tuesday. Wednesday, basically, in my office or any classroom in between. Okay? Thursday, from 8 o'clock in the morning until 3:15, anywhere. But 3:15 is technically when the mini-term class has their final. So if any of them want to wait until Thursday to take their final, they can. I'll be up here in this classroom from 3:15. I doubt if I'll be here longer than 4 o'clock because it's not that long a final and we don't have to do a lab, so I'll probably be through here. So anytime then from 4 o'clock until 8 o'clock, I'll be either in my office or in some room in between. Then Friday, I'll be on the Birmingham campus, 7:45 to 11:45. And then the next week, Monday, finals are over. Most of the time, we have until noon on Monday to get our grades up, okay? Sometimes they give us another day, like Tuesday. If they do, then that's another day. But if I have to have a noon on Monday, that means I've got to have all your work in on the week before. I've got to. I can't wait and get it in at 11 o'clock on Monday and get it graded in the grade book and all like that. I need it in. Okay. If they give us till Tuesday, then yeah, that we do. But I don't know if they're going to give us an extra day or not. All right, and then this one other thing. You've been a student here before, right?
Yes.
Okay, so you may know this already or you may not realize it. During final exam week, Student Suite is shut down. I don't know if you remember that. The thing is, our ancient, ridiculous old system that we have, there are only something like 16 or 32 portals to the whole system. So that means if students are checking their grades in Student Suite, only 16 or 32 can be on there at one time, and then we can't get on to put the grades in. So in order to leave those open for us, they shut students out of Student Suite during Finals Week. But it really doesn't matter because I and most other instructors are going to put the grades in Blackboard first. Blackboard is always going to be open. So look at Blackboard first during Finals Week. If you see your grades there, that's what's going to show up in Student Suite when you are able to see it. If you don't see it there, that means we haven't gotten it there yet. So you would be in Student Suite anyway. So during Finals Week, check Blackboard, not Student Suite. After finals are over with, after that noon on Monday or Tuesday, whenever it is, deadline for us to get the grades in, after that, Student Suite's open again, so you can look at each one of them. Okay. All right. Any questions? Okay. All right, let's go on with this. Now, what we're talking about are vector spaces. And what a vector space is a set, okay? Set of objects, okay? But they have to meet certain criteria. Now, the two things that you have to have for that set, they have to be defined to be vector addition and scalar multiplication. Okay. Now, before this chapter, a vector was a directed line segment, right? That would be a vector. Okay. Now, a matrix can be a vector. A 3x2 matrix can be a vector because you can add 2x3 matrices together, you get a 2x3 matrix. You can multiply by a constant, you still got a 2x3 matrix. So that can be a vector. A set of polynomials can be a vector. A set of continuous functions can be a vector. I mean, just about anything, not anything, but a lot of things. So here is a set, in R2, okay? Generally, R2 is a vector space, okay? This is a set of all ordered pairs of any real numbers. X and Y can both be real numbers, any real numbers. However, in this one, they've redefined our scalar multiplication. So if this is our vector, set of ordered pair, x1, x1, x2, if that's our ordered pair, if they define scalar multiplication in the old way, that would be cx1, cx2, that's a vector space. But if you redefine this and say, no, I want vector multiplication to be, or scalar multiplication to be this. Multiply the first one by cx1, but the second one, make it 0. Every time make it 0. Okay? Is that now a vector space? Well, let's think. If this is an ordered pair, that's certainly an ordered pair. That works, okay. But what you do, you look back at the, a couple pages back, those 10 definitions. We've had about 3 or 4 different times for different spaces. Every one of those must fit. Okay, let's skip down to the last 5, the scalar multiplication 5. Cu, the way we've described it here, is in V. It's a set of ordered pairs. No problem. Now, the number 7 works too. If you have C times x1, x2, plus C times y1, y2, those are ordered pairs, that would be cx1, 0, plus cy1, 0. That's certainly still the same. That's no problem there. But if you have C plus D times U, yeah, that's still no problem. Ha! Here's the one that you don't. Here is the requirement. 1 times x1, x2 must equal x1, x2. Well, wait, I think that still works okay. No problem there. Oh, yeah, right, okay. No, it has got a problem, okay? Because for any C here, C times the vector has to be that. Well, if you do the C being 1, this would be, I thought it was, but when I looked at it there, I thought it wasn't. That would be, by that definition, that'd be 1 times x1, 0. Well, guess what? 1 times a vector is not the same vector. It's a different vector. So this is not a vector space, because all 10 of those steps must be done. So sure enough, that's not a vector space. Sorry. That finishes 4.2. Oh, and that finishes our time too. Homework exercises here: do any of the odds 1 through 5, any of the odds 7 through 11, any of the odds 13 through, goodness gracious, 13 through 33. Then do any of the odds 30, well, do 35 if you can. 37's a proof. Take a look at that, see if you can do that one. 39, see if you can do. 41 is the mass spring system, which was the linear algebra applied at the bottom of page 158. See if you can do that one. Then 43, see if you can do that one. Sorry. And then after that, you got true false. You can read through that. You got some proofs. Next time we'll pick up with 4.3 and talk about subspaces. Okay, it's a pretty short section, so hopefully we'll get that done and hopefully get into 4.4, which is spanning sets and linear independence. That's probably going to be as far as we get, because that's a long section. I doubt if we can finish that. I wish we'd get into basis and dimension, but it looks like we're probably not going to make it. So if that shows up on the test, I'll say that's going to be optional. All right, good deal. Any questions?